And so we ended up talking about this z-score. And again, as I would stress, make sure that we understand why this is like that. And as I said, all of these distributions is just not a simple normal distribution of the population. No, it's not. It is the sampling distribution of this sample means. It means that all of these values, all of the values that you see in here, are all means coming from a certain sample. And as we talked about many videos ago, each of those samples would have its own sample size. That's the reason that they have their own means for each one of those. And because of that, the standard deviation would have differences from the population itself. And the way that we represent it is if you wanted to compute for the standard deviation of this, then it would be equal to the standard deviation of the population all over square root of n. So if we're going to use this based on the standard deviation of the population, we need to make sure that we use this formula correctly. But then again, make sure this would not confuse you. This thing is equal to the standard deviation, alright, SD, capital ST, of the sample means, as I said, because each one of those red lines are means coming from a sample of a particular sample size. Alright, now let us say that we were able to compute for mu1, right? And we got a value for z. Let's say our value for z was z or z1. And let's say that a z1 was found out to be more than 3 standard deviation of the sample means. What it means is, if it's 3 standard deviations, if z1 is more than 3 standard deviations, because remember, the z-score would tell us how many standard deviations away you are from the mean. So really the result of this would just be a number, and the number would be z1 is more than 3. But I'm just writing 3 standard deviations of the sampling means for us to really understand what the z-score represents. And from that, we know that 3 standard deviations away is quite far. It is actually around here. So I would mark it as z1. Alright, that is where z1 is. And for us to understand what z1 is represented in this distribution, we need to obtain its probability. What is the probability of z1 happening? As I said before, this is a way to know if mu1 belongs in this distribution, is to find out what is the probability of z1 happening. Now, the most important thing in here is for us to understand other properties of the normal distribution. We cannot just get the probability of a single point. We need to get the probability of a range. So what we can do is, instead of getting the probability of just z1, we can get the probability of statistics which is more than or equal to z1. So we can get, and writing it down in the right way, is we can get statistics where zi, a particular statistic, is more than or equal to the value z1. And how do we do that? Well, as I said before, we just need to do the cumulative distribution function. And from the cumulative distribution function, we would realize the value for that probability. And if it is actually 3 standard deviations away, its probability is quite small. And if I would check it,